You guys didn't give me permission to film me, but you're going to be filmed, so you're good colleagues. All right. So today I'm going to do introduction to parabolas, especially focusing on factored form for the intro. If I were to do this in a unit, this would be my intro to parabolas, but I wouldn't have gone over quadratic equations yet, so that's why I'm choosing factored form. So our learning outcomes for today: identify the vertex, axis of symmetry, and intercepts of a parabola by looking at the graph a parabola using factored form, and find the equation of a parabola in factored form using the graph. All right. So first, this word for a lot of 8th graders, because that's about maybe 8th or maybe even 10th grade in an Algebra 2 class is where you're going to see this. So the word parabola kind of seems scary, because like before now they're just working with lines on graphs. So I broke it down. So para means beside, alongside, parallel, and bola means ballistics, or something being thrown. So every time you throw something, Gracie, it makes a parabola, and that's what that little arch is. So, pass it back. Woo. All right, so this is, I think, the first page on your little note-taking guides. We're just going to go over some basic terminology. So first, you're going to hear people talk about opening up or opening down. So can anybody tell me which one this parabola is doing up here?
Opening down.
Opening down, perfect. Next, you're going to hear vertex, which to graph it, you need this every single time to graph your parabola. So this is also considered either the minimum or the maximum point. So if it's opening up, it's going to be a minimum point, and if it's opening down, it is going to be a, down, yeah, it's going to be a maximum. All right, so next what you're going to hear is axis of symmetry. So this is a line over which you could fold the parabola in half, or I've also heard it called a butterfly line, because butterflies are kind of what we think of when we think of symmetry. So if we're going to cut this parabola in half, if we want it to be the same on both sides, that would be our axis of symmetry. So it's going to be right at 2. But if you're going to see this on a worksheet or anything like that, you can't just put 2, right? Because, well, that could mean right here. And why can't that be our axis of symmetry? Does anybody know?
Not symmetrical.
It's not symmetrical, right? If we folded it over, that wouldn't be the same on both sides. So when we write 2 for a parabola, that means it's going on the line x is equal to 2. All right, and then the last term that we kind of have to talk about are intercepts. So we've talked about this with lines. That's where it crosses one of the axes. And today we're especially focusing in on our x-intercepts. So here, it crosses at 0, and it crosses at 4, but we have to remember that these are points. They're not just numbers. So over here, it'll be at 0, 0, and over here, it's going to be at 4, 0. So we have to remember to actually put it into coordinates and not just leave it as whole numbers. All right. So I'm going to give you guys a minute, and then I'm going to have you guys take turns coming and filling this out. I believe this is their second page on your note-taking guide. So I'm going to give you guys a second to try and use that terminology yourselves. Then I'll kind of call you up to come fill in the blanks. All right, and there is 5 of you actually. It works out perfect. So whenever one of you wants to come up, come fill in one of these blanks. So, and for this one, you can either circle up or down. And then eventually, all 5 of you will be up here, and then we'll have it all filled out. So whoever wants to go first can fill something out. Easy one, yeah. You want to fill out the other one too? Thanks, guys. the other x-intercept. Yep. Thank you. That's okay. The other day when we had a math one, like I was messing up all over the place.
Rachel did that line.
No, just can't fill out yours. We're all about participation here.
They answered your question.
We're a small class, takes lots of participation.
This one.
Yeah, perfect. Sweet, so our axis of symmetry is gonna be this line right here. And this graph is, you kinda have to be careful about how this graph is scaled, right? Because 2 is right here, so we can't just be counting these lines. We have to be aware of how it's scaled. But yep, it's gonna be x equals 1, and then our y-intercept would be 5, 0, comma 5. We just have to remember to put it as a coordinate. Alright. So now we're actually gonna skip to graphing parabolas. But at this point, we still have everything we need to know to graph it. Alright. There we go. Alright. So how I like to start graphing my parabolas is I usually start with the x-intercepts if they're already given. So we know how to plot points, so it's over 2, there, over negative 6, 1, 2, 3, 4, 5, 6. This graph goes down to 10, so we'll go 1, 2, 3, 4, 5, 6, over 2. The hardest part about graphing a parabola is making it look symmetrical. There we go. Alright, so this is how we graph it. Pretty easy. It's just like a line, except you need 3 points instead, right? So can anyone tell me if it opens up or down?
Up.
Up. Does it have a minimum or a maximum?
Minimum.
A minimum. Perfect. Now can anyone tell me what the axis of symmetry is? It's kind of hard to see on this one. And if we can't see it, does anyone know another way that we could tell what it is?
Does it give me negative
On
2?
X point.
Yeah, exactly. We have to look at the vertex. Right here, right? Because parabolas, they're always going to be going up and down this way. It's actually a different graph if they're going the other way. So our axis of symmetry is going to be the x-coordinate of our vertex. Alright, so now we're going to actually get into the terminology of what does factored form kind of mean. Alright, and I will have you guys just keep in mind this is before I get into quadratics, so kids probably haven't worked with factoring quite yet. So I'm describing it in general form as we have our 2 x-intercepts, which can also be written as a negative h and a negative q in coordinates. And then our a, which I'm calling our stretcher. And I'm going to open up Desmos to kind of show you guys why I call it that. Right, let's see. Oop, maybe x minus 1, x plus 1. Alright, so here we just have a pretty simple parabola, right? Its vertex is right here at -1, it crosses at 1 and -1. So here's our formula up here, if you can't see it too. So I'm going to change where that A would be. And I just kind of want to watch us see how this changes. So if we do a 2, or a 3, or a 1/2, I call it a stretcher, because I kind of think about it as Laffy Taffy, right? It's pulling it in different directions. And one more thing I'll show you while we have Desmos up, which we won't work with too much now, but also, if you change the sign, it changes the up and down direction of your parabola. And that's something that we'll cover later on, called transitions of a parabola, but for right now, that's kind of what our A does. Okay. Shoot. So, can anyone tell me now what we need to graph a parabola? X-intercept, perfect. And then what else? What's crucial?
Vertex.
A vertex, exactly. So, how I parameterized it is we need the vertex, and then we need a point on each side. And for factored form, we already have the x-intercept, so it works really well. But if we had a parabola and we just had the vertex of it, we could just choose 1 unit to the right and 1 unit to the left, plug in our x's and get our y's for those, and it would still be 2 on either side of the parabola, and you could graph it. All right, so this is one we're gonna work through together, and then the next one, you guys do it on your own. So here we're looking, well, I already have my x-intercepts, right? But we have to remember our x-intercepts actually look like this. So if I'm looking at my h,
So why are those called H and Q?
they're just random variables. I could even put, if I wanted to, I could put like negative star and 0. It wouldn't matter. Yep. And I always like to choose things other than x and y for different problems, because that way if kids are on the ACT or something like that and they switch out the letters, they don't think it switches meaning. So it just kind of like reinforces the idea of it is a variable and it could be anything. So, yep. All right, so our first x-intercept is going to be positive 6, because it's the inverse or the opposite, right? 0. Then this one over here is going to be negative 2, 0. And while we're here, does anybody know why it's the inverse? Why does it work like that? So that's because we know if something's crossing the x-axis, that's where y is at 0, right? So if our y up here is at 0, and all of these are being multiplied together, all we have to do to get an x-axis is make one of these things equal 0. So that's how we get these. So if you can't remember if it's the inverse or not, here. If we can't remember if it's the inverse or not, we're like, well, we just have to make these 2 different things equal 0. So it's going to be 0 is equal to x minus 6, which will get us x is equal to 6, which is that one. And you can do the exact same thing with this one over here. All right, so we know how to do that, so let's plot those. 1, 2, 3, 4, 5, 6, then negative 2, 1, 2. All right, so now we're looking, and then we didn't just get our vertex. Well, how can we do that? So I'm thinking, I know my vertex has to be right smack dab in the middle of these points, right? Well, right smack dab in the middle is positive 2. Well, if I have one coordinate to any like pair of coordinates, I can find the other one if I have the equation. All I have to do is put 2 in for my x. So let's do it. So it's y is equal to 1/2, 2 minus 6, 2 plus 2. So it's going to be y is equal to, I won't skip over our algebra steps. Negative 4, positive 4, y is equal to negative 8. All right, well, since we put 2 in, it'll be over 2 and down negative 8 for our vertex. Over 2, down 1, 2, 3, 4, 5, 6, 7, 8. And there we have it, our vertex with 2 points on either side. So as I clean the board, I want you guys to get started on the your turn problem. And you'll see in there that, just kidding, it's not on this one. You'll see in there that exactly what's on the board. Yep. Number 1 participation. I know know, with my hat, that's not the best choice for a projector screen.
There we go.
Perfect. Alright, somebody have the vertex? Sweet. Thank you. Alright, go through, connect our dots. Maybe. He's dying. Any disagreements? Sweet. We'll move on. Alright.
Was that -8 on the vertex?
Ooh.
Or was it -6?
Let me go back. Oh, wait, I suppose it's right there.
Or 9? I think it was
9. Yep. Alright. So now we're getting into, really this is more what our activity is going to be having to do with, is this kind of problem here. So what is the equation of the parabola with x-intercepts of -3 and -15 and a vertex of -9, -12? So, and then I'm having you graph it just for practice. We don't even need the equation when we have all that to graph it. So I'll graph it for you guys quick. But I want you guys to think, how would we do that? I'll give you guys just a minute to think while I graph it and then I'll start on it. Alright, so I'm going to start explaining it, and then our next one is similar to this. It's going to be another your turn, so I'll do this one together with us. Alright, so I already have my H and my Q, right? My H is going to be 3, and my Q is going to be 15. And remember, those are totally interchangeable. It doesn't matter which order it goes in, because it doesn't matter where that 0 is. If it's being multiplied, that whole side is 0. Alright, so here. I'll put it over here for us and I'll kind of get out of your guys' way afterwards. Alright, so we always start with our y equals. We know we're going to need an a somewhere in here, but we don't know what it is yet. But we don't want to forget about it, so I always write it there. Then we're going to have x plus 3, x plus 15. That was a bad five. There we go. Alright, so we have this. Now this is something new. We haven't had to solve for our a quite yet. But we have this nifty little vertex here. So all we have to do is plug in our x and our y, then we can solve for a using good old algebra. Alright, so -12 is going to be our y. It's equal to a. And then our x, -9. So -9 plus 3. -9 plus 15. Alright, so comes out to be -6 times another +6. A is equal to -12. Alright, well if we multiply these together, I'm going to kind of come over here to save us some room. So we're at -12 is equal to -36a. Alright, well let's divide by -36 on both sides to get our a by itself. So it's going to be +1/3 is equal to a. Well, now that we have all of our pieces, we can just plug everything back in. So it's going to be y is equal to 1/3. There we go. X plus 3, x plus 15. Alright. Again, while I erase the board, I'm going to have you guys go ahead and start on the your turn. And on this one, you're going to see that I wrote in the vertex because I printed these all at the same time without proofreading, and I forgot to put that in there. But it should be written on all of yours. It's -4, -4. It's on the board. Alright, Seth, do you want to come graph it for me? Sweet. Alright, can somebody come write up the equation for me? If they have it? Not Gracie or Kayla, they come up here already. There we go. Thank you. Alright, so does that mean we just don't have an A for this one?
No.
So what does that mean? I don't see an A though. It's 1, exactly, right. And when there's nothing out front here on any X, right, it's also a 1 just sitting here. It's a good algebra reminder so we don't forget. Alright, so this is the last like two little problem chunk things that we're gonna go over. So now we're finding the equation using the graph. So now we have to pull it off the graph, the pieces we're missing. Alright, well, we know we already need our x-intercepts and our vertex. Those are pretty easy to pull off the graph. So, our vertex is gonna be right here. This time it's 0, -1. Suppose I can put that over here where it goes. 0, -1. Alright, and our x-intercepts, both pretty easy. +1, 0, and -1, 0. Alright, so now that we're here, we do the exact same thing we did last time, right? All we had to do is pull that information off of the graph. So we'll walk through it again, it's always good to see it a couple times. So at this point, we're at y equals a times x minus 1, x plus 1, put in our vertex, so that's x, so it's going to be -1 is equal to a. Well, we don't really have to even put the 0 there, right? We can just put -1, +1, -1 is equal to a times -1, so 1 is equal to a, just like last time. So it's going to be y is equal to, and I'll put the 1 there just so we can see it, but Elliot was totally right last time. He simplified it and didn't even put it there. And then x plus 1. Alright, so it's going to be another your turn problem. As I erase the board, go ahead and get started on it. Oh, that was the right answer. Ooh, there we go. Alright, so I'm guessing everybody has their x-intercepts. So it's -2, 0, 6, 0. Then our vertex is over 2, down -8. Somebody have the equation? Do you have the equation yet, Rachel?
Oh, no, I missed that. I thought it was 5.
No, you're good. Alright, somebody want to come work through it this time? Not just write it on the board. It's a little more daunting of a task. Alright. Perfect. Does everybody agree? Awesome. Alright, so now, if I remember my slides correctly, I think we could get started on the fun stuff. Alright. Sweet. Alright, so I'm gonna explain the activity and I'll hand out, or I'll have you guys take one, pass it down for the worksheets as I do so. So, here we go. I'll hand you guys the front row, and you'll probably have extras, so you can just keep them on the end for now. There it is. Alright, so for this activity, we're gonna be in groups of 3. And I think that'll still work out. You can look around the classroom and you'll see that I've taped some coordinate grids up on the wall.
That was funny.
And each group is gonna go to one of these coordinate grids. So you're gonna take turns creating your parabola. And I'll show you what I mean by that. Alright, so I have one ball for each group, and pretend this is our coordinate grid that's plastered around our walls. You're gonna have one classmate over here with a phone, taping you, while the other one throws their ball against the grid and makes a parabola, okay? And everyone's gonna have a different one, so all of your worksheets will look different. That way we can like practice working through some different numbers and all that. So essentially your partners are really just needed for the filming part, but I do encourage you to work in groups, obviously, if you're confused. And I'll walk around and help you too. But this way, it's a good practice in actually seeing mathematics in action, right? Because most of the time we're just graphing lines and it's just kind of boring. But this is actually something like everybody throws a ball in every sport ever. So it's fun to actually see it work. All right, and then, so on that worksheet you have in front of you, there's a graph. So after you make your parabola, and you can like slow down your recording or pause it, go ahead and recreate that on your worksheet. And then identify all the pieces it asks for on the worksheet, the vertex, maximum, minimum, axis, symmetry, x-intercepts. Then finally, I want you to find the formula of the ball that you threw. And last but not least, say thank you to my dog. These are his tennis balls that he is letting us use today. So, and his name is King. Alright, so if you guys want to split into groups of 3, and then you guys need to get a tennis ball from me and spread out to the different grids in the room.
I don't know.
We